functions that we talk about when we talk about overlaying and geoprocessing. We're going to talk about dissolve, buffer, append, and merge. Polygons on a habitat class. And so when you start doing overlay functions, a lot of times what happens is you end up with lots and lots and lots and lots of tiny little polygons. And sometimes it's better if we join those together. And so what we can do is something called a dissolve. And basically you select an attribute, a field, if you will, a column. And within that column you select to dissolve, and it will go through that column or that field, and it will find all the possible answers that are there. In this case it would be B's and C's and F's, okay? And it will then take all those B's and put them together as one, all those C's and put them together as one, all those F's and put them together as one, much as like you see here on the right. And so for example, if you had certain values that you could select from, you could dissolve on and create any number of features that way. So it eliminates all of the attributes in the table except for the dissolve one, but you can summarize other attributes if you like. And so if you do the dissolve, it's going to kind of just give you that feature. If you want the other information, you got to kind of work for it. Buffering is another common technique. Basically, buffering constructs polygons areas within a specified distance of a feature. Here we have multiple buffers around points, and we have single buffers around lines. They are useful for establishing proximity. Append is another common feature that we come across and use. Append places features from one feature class into an existing feature class of the same type. So it takes some lines that's in one data set and adds them into another data set of lines. It takes data set of points in one data set and adds them to another data set of points. Here's the thing that you remember. The features that are brought in are simply brought in, and so if they overlap, you're going to have two of them. If you bring attributes with features, the attribute table will have two input layers with the exact same stuff. Appending a data set can be dangerous because you can end up with a lot of duplicate stuff that you may not realize is there. Merge is a little different. Merge combines two data sets, but it doesn't modify either of the original data sets. It creates a new output. This new output is made up from those individual inputs. It does not attempt to split or change features, and if things overlap, it allows it. You can use the field map option to control which input fields are included in the output. So you can keep some or all or none or whatever that you want of the attributes. Efficient overlay is kind of one of those concepts in GIS that we just need to do all the time. Overlay is time and memory intensive. It takes up a lot of computer effort. And so what we want to do is minimize the number of features that we're working with. To efficiently overlay stuff, we need to do things like dissolve the vegetation before intersecting with other layers. So if, for example, these green polygons are different vegetation types, but there's really only two types there, there's just lots of polygons of it. If we dissolve by that property, we can then make it so that we're dealing with much less number of polygons to deal with in our overlay function. One of the other side effects of overlays is something called slivers. Slivers are these tiny little polygons that get created during the geoprocessing, and they usually happen because boundaries of things that should line up don't line up exactly. And so you have two different data sets. One, for example, is a geology layer, and one is some sort of other data set, maybe soils or something like that. And there's a strong correlation between when soil types changes versus the parent geology underneath. So when you go to combine these things together, they should be lining up pretty close to the same spot, but maybe they don't, and so you end up with a lot of little tiny things. That can happen. A lot of times what else causes it is when you have multiple operations. So when you do the old two-step where you combine this with this and you combine it with this and then you combine it with this and et cetera, you can end up where you have multiple overlays taking place, and what will happen is eventually you just end up with a bunch of these tiny little slivers, and they can create a lot of problem for applications. You go to do something, process something, and you're thinking it's a reasonable sized data set, and all of a sudden you've got a million freaking polygons, and you're like, where did all these polygons come from? Well, the majority of them are these tiny little slivers, and they can basically grind a lot of processes to a halt. So it's important that you recognize the need to get rid of stuff like this and to set boundaries to take care of it. So how do we do that? Well, tolerances is the big thing. We can use this to reduce problems. The thing about tolerances is they're tricky to set. They're no good if you make them too small, because then basically it doesn't stop anything. If you make the tolerances too large, it degrades the accuracy of your final product, and so it affects the output layer. So when you do multiple geoprocessing steps, that can progressively degrade the accuracy, even if you have the tolerances right. So you need to really think long and hard about your various overlay functions and how you bring things together and how you manage things like slivers. So what are some of the other analysis tools we can look at? Pretty straightforward tool, really. Has a lot of options. You'll use it. Dissolving. Some examples of what that looks like. Buffering. With buffering, you got to pay attention to a couple of things. The distance, set up the units, and that kind of stuff. Dissolving, whether you dissolve around the features together or not. You have to think about what's important and what you need to do. Lengths and areas of features. This is something we will talk about multiple times before you graduate. Areas and lengths are important. Tools change these, so you need to make sure that you get these numbers right. And how do you get them right? You update those geometry fields. So remember this: geodatabase shape underscore area and shape underscore length are automatically updated. Other fields are not. Shapefiles are not. Assume these numbers are wrong and then correct them. How? Updating the length and the area is simply select the field or the column, if you will. Right click, calculate geometry. It pops up. You select the property, the coordinate system, the units, click OK. It then repopulates that field with numbers that are correct.